Okay, so this should be the final exam review for packet number 2, numbers 1 through 10. So we'll be going through this relatively quickly. This is supposed to be a guided review of these 10 questions. So in theory, you should not be listening to this video until you have tried these 10 on your own. So the first two problems on the packet deal with the number sets, which if you remember, there is actually a diagram for this in your notes. That is, we're looking at what I like to call the dartboard. And within that dartboard are a number of different number sets that we have talked about pretty extensively. Okay? So you should be dealing with this pretty simply. The very inside here are the natural numbers. Just beyond those are the whole numbers. Just beyond those are the integers. Outside of those are the rationals. And then we have the irrationals attached to those. And then we have the real numbers making up the entire set. So if you don't remember, the natural numbers, these numbers all the way in here are 1, 2, 3, 4, 5, 6, 7, 8, 9 up to infinity. The only difference between the whole numbers and the natural numbers is 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. The integers include your positive and negative integers. And the rationals is any number which can be written as a fraction, which includes your terminating and repeating decimals. And the irrationals are your non-repeating, non-terminating decimals. Now when we put the irrationals and rationals together, we get the reals. So this says classify negative square root of 31. So the question you have to ask yourself is, can that be reduced? And the short answer is no. The square root of 31 does not reduce. So the square root of 31 should be getting placed over here in the irrational numbers, which means the best description for it would be irrational and real, or letter A. Again, any number that's irrational is also real. Any number that's natural is also whole, is also an integer, is also irrational. I'm going to grab this and take it to the next page so we can use it there as well. So I just want a picture of that to take to the next page. Okay, so here's number 2. Same directions. So we're going to do something very similar. We're going to take a look at our dartboard, and we're going to ask ourselves, 6 over 3. Does that reduce? And the answer is yes. That is equivalent to 2. 2 is a natural number. So 6/3 would go in here, in the natural numbers. Okay? So if we're placing it in there, 6/3 inside the natural numbers, means that that number is a natural number, a whole number, an integer, a rational, and a real. A natural, a whole, an integer, a rational, and a real. So the best description provided, none of these are perfect because none of them include natural numbers. The best description would be B, because 6/3 is equivalent to 2, which is a whole number, an integer, a rational number, and a real number. It's actually also a natural number, but for whatever reason that is not included. On number 3, it asks you to write that set of numbers in order from least to greatest. I would hope that everybody would realize that the negative number would be the smallest number there. So -6 should come first. Then if we look at the two remaining numbers, 1.5 and 5√2, we should easily be able to use our calculator to realize that 1.5 is smaller than 5√2. And we should be able to order those numbers, -6, 1.5, 5√2. On number 4, this is simply order of operations. We're supposed to reduce this expression down to a single number. So we would start with the parentheses on top. 18 minus 2 is 16. And on the bottom, we can do the 3 times 2 to get 6. So we'd have 6 plus 6 on the bottom, plus 5. On the top, then, we would do the multiplication. 3 times 16 is 48. On the bottom, we would do 12, or 6 plus 6, which is 12. Then the division would come next. That would be 4 plus 5, which means A equals 9. Again, that's all PEMDAS. Everybody in this class should know what PEMDAS is. Number 5. Okay, here we go. Here's a word problem. Stephanie spends $8 each month to belong to a photography club. As a member of the club, she can develop rolls of film for $2.25 each. Write and solve an equation to find the total amount Stephanie will spend this month if she develops 6 rolls of film. So, we have there a base fee of $8 each month. That is an intercept. And we have a cost for each roll of film. That is a slope. So our equation, where y is the total cost and x is the number of rolls of film, we can write an equation in y equals mx plus b form to describe this situation. It would be y equals 2.25x plus 8. Now, the problem itself actually tells us that she wants to develop 6 rolls of film. So we're going to let x equal 6 and evaluate for y. So 2.25 times 6 plus 8. 2.25 times 6 is what? $13.50. I guess I better check that. $2.25 times 6 rolls of film is $13.50 plus $8 means that she will spend $21.50 to develop that many rolls of film. It should get us through the first page, I believe, but we're going to continue this video until we're through the front and back of the first page, so that would be pages 1 and 2. Express each relation as a graph and a mapping, then determine the domain and range. So they've given us a list of ordered pairs. They want us to rewrite it as a graph and as a mapping. Now, I didn't include a coordinate plane, but let's be honest, you could probably draw your own without too much of a problem. I'm going to cheat, because I can, and insert a coordinate plane so that we can graph this. I'm going to make it a little bit smaller, though. It's pretty big there. Okay, so to turn it into a graph, all we do is graph those points. So let's see. 3, negative 4 would be right 3 down 4. 1, negative 2 is right 1 down 2. 3, 5 is right 3 up 5. 3, 0 is right 3 up 0. And 1, 5 is right 1 up 5. Okay. Then a mapping. A mapping is where we have a domain bubble and a range bubble. Should make the writing the domain and range pretty darn easy here. And each ordered pair will provide us with a input and an output value to put into that mapping. So we have 3 points to negative 4. 3, negative 4. 1 points to negative 2. 3 points to 5. Notice I am not writing another 3. We don't repeat. 3 points to 0, so I need a 0. And 1 points to 5. So there's the graph, there's the mapping. Now we need to determine the domain and the range. So the domain is a list of the x values, the inputs, the values of the independent variable. That would be the numbers 1 and 3. And the range, that is a list of the y values, the outputs, the dependent variable values, which would be the numbers in the range bubble. We usually do like to write them in ascending order, meaning smallest to largest. So that would be negative 4, negative 2, 0, 5. Now, while we're here, bonus question. Is this a function? Pause the video and decide. No, it is not. This is not a function because 3 repeats 3 different times in the domain. See the 3 arrows starting from 3? And 1 repeats twice. This makes both 1 and 3 repeated domain values, which makes this not a function. All right, now I think we're on to the second page. So, indicate the answer choice. Best completes the statement or answers the question. The following table shows car sales at a local car dealership for the first 7 days of October. Identify the independent and dependent variables in the October car sales table. So what this is asking you to do is figure out which one of these two variables, days or sales, is your independent variable and which one is your dependent variable. You should remember from when we talked about this back at the beginning of the year that time is always independent. So if we're looking at these two values, days is a time, sales is based on days. So day would be your independent variable and sales would be your dependent variable, meaning D is the correct answer. Okay, number 8 asks which one of these relations is a function. And again, to tell if it is a function, we are simply looking for no repeated x values. So if we look at these, 3 out of the 4 of them, we should have a repeating x coordinate somewhere in the list. For instance, on B, 5, 3 and 5, 7. That makes that not a function. On C, negative 5, negative 5. That is not a function. Let's see here. On A, 2 and 2. See how there's a repeated x? That is not a function. So the correct answer is letter D. That is the only one with no repeated x's. That is the only function. All of the others have a repeated domain value, which makes them not a function. Number 9 is evaluating function notation. Simple problem. To find g of negative 6, we simply plug negative 6 in for x everywhere in the equation and then evaluate. So that would be negative 6 squared plus 3 times negative 6 minus 2. That is 36 minus 18 minus 2, which would be 16. So g of negative 6 is equal to 16. Now remember, this is notation, so we don't do anything crazy like try to divide by negative 6. That's the answer. G of negative 6 equals 16. Now remember what that says. That says when x equals negative 6, y equals 16. It's a point on that function. And finally, number 10, this is the last problem on the second page. This graph shows the height above ground of a baseball during Kyle's home run. It asks you to identify and interpret the x-intercept. So the x-intercept is where it crosses the x-axis. It's that point right there. So the x-intercept is the point 2.50. Now when it says identify and interpret, it wants you to state what that point represents in the context of the problem. So 2.50 indicates that the ball hits the ground 2.5 seconds after being hit. And I believe that that will do it. 2. Again, seconds is coming from the units over here on the graph. That should do it. That should be the end of the first 2 pages of the review packet.